Hello everyone, in this video we will be discussing about the programming language question of the year 2015, 16 and 17 of ISRO Scientist Engineer Computer Science question papers. So let's move on to the questions. Okay, in this, consider the following program fragment. We have a fragment and we have to tell when will the statement S2 would be executed. Okay, see, it is if A is greater than B. So it is the first condition, and this else is for this if. Okay, so this, it is like it starts over here and it ends over here. It is like this. So if A is greater than B, so S2, that is this condition, is must, that is A should be greater than B is must. Okay, and so D should be our answer, but let's see if some other condition are there or not. And if B is greater than C, then S1. If B is not greater than C, then S2. So what is B is not greater than C? That means B should be less than or equal to C. Okay, so if both these conditions are true, then only the S2 would be executed. So this is option D. This is our answer. Okay, next question. If n has 3, then the statement, okay, it is n as 3, then the statement this is equal to a n plus plus. Okay, actually this is a compiler dependent statement. It depends on the compiler. Next, these are the questions which are asked in 2015, the previous ones also. Okay, here we have a main method. In this we are calling the increment function 3 times. Okay, now we have a static integer x. Okay, we have a static integer x and we are printing the value of x plus x in the increment function. Okay, see, what a static int does means, if the function is called, suppose the first time the value of x is 2. Okay, if the function is called again, it would remember the value of x. Okay, if we are incrementing the value of x by 1, it would increment this 2 by 1. Okay, not the original value, not the previous value. Okay, the recent value. Suppose it is x is equal to 3. The next time the function would be called, it would increment this 3, that is x is equal to 4. So that is the purpose of the static int. So now let's see how it works. We are calling the increment function. Okay, so the static int is by default value of static. Any static variable, the default is 0. It is initialized to 0. So if you haven't initialized this means here x is equal to 0. Okay, so the answer would be, so this is wrong. This won't be our answer. That is, it print 3 consecutive but unpredictable numbers. No, we can predict the number because the default value is 0 is the default value. So x is initialized to 0. And the first time it is called, x would be 1. Okay, the second time it would remember the value of x is equal to 1, it would be 2, and the third time it would be 3. So the answer would be 1, 2, 3. That is B's option. Next question. Consider the following fragment. So we have this question over here, and what are we doing? This is some code. On termination, we have to print the value of j over here. Okay, let's see what is the condition. We have I mod j. If I mod j is equal to 0, then these things would happen, else the loop will terminate. So let's see what is the value of j. Okay, value of j would be the number of time the loop runs. Okay, we are just, it is a loop counter. It is a counter variable, that is j is equal to j plus 1. So it would be the number of time the loop runs. So let's see now. For the first time, j is equal to 4. Okay, instead of 4, it was 0, it is initialized by 4. So value of j would be the number of time the loop runs plus 4. So we will be initializing j by 4 only. So first, I is, that is, we will be checking the condition, that is I mod j. I is 6720. Okay, mod j is 4. Okay, so it would be divided by 4, yes. So it is equal to 0. That means my loop would run. If the loop runs, then I is equal to I by j. So I is equal to 6720 divided by 4, and it is equal to 1680. Okay, and we are incrementing the value of j by 1. So j is equal to 4 plus 1. It is 5. Okay, now next we will check this. That is 1680 mod. Now our j is 5 mod 5. Yes, the last digit is 0, so it would be divisible by 5, and I is equal to 1680 by 5, and it is equal to 336. Okay, and we would be incrementing the value of j by 1. J is equal to 6. Next, we have 336 mod j. J is 6. Okay, yes, it is divisible by 6. It is equal to 0. Then I would be, it is 336 by 6, and equal to 6 5s are 30, 6 6 are 36. It is 56, and j is 7. Now next, it is 56 mod 7. Yes, it is divisible. It is equal to 0. So I is equal to 56 by 7, which would be equal to 56 by 7 would be equal to 8. So the value of j is 8. Okay. Last we have 8 mod 8, which is equal to 0. Okay. So 8 by 8 would be a I. So the value of I at the end of the loop would be 1, and the value of j at the end of the loop would be 9, because next time we would be, it is like 1 mod 9, so it is not equal to 0. So the value of j is 9 at the end of the loop. So C is the answer. Okay, so in case on termination the value of I would be 1, and the value of j would be 9. Next, consider the following declaration. So we have a declaration here. So the following program fragment. So okay, so what we have here is we have A, which is 4, okay, and we have B, which is pointing to A. That is, B points to A. That means B stores the address of A, and we have C, which is pointing to B. Okay, and what we are doing is we are the value. What does this mean? What does this mean? This is the value where the C is pointing is equal to 5. That is, C is indirectly pointing to what? 4. So value where C is pointing is 4. Sorry, it should be equal to 5. Earlier it was 4, now it should be equal to 5. So the value where C is pointing, it should be equal to 5. So answer should be D. It assigns the value 5 to A. Okay, next question. Okay, in this question, we have given an array, and it has been declared as static, and we have given 2 loops, the first one and the second one. The first one, there is some logic which would make some changes to this array. In the second one, it is just printing the array. So we would see the logic from the first one only. Okay, this is our array, and we have index 1 2 3. I'll write it like this only. This is our index. Now see, for I starts from 2, increments by 1 till 6. So it would run for I equal to 2, it would run for I is equal to 3, 2, I is equal to 3, it would run for I is equal to 4, and it would run for I is equal to 5. That's it. So see, now what is the logic? X of I. So here x of I is x of 2. So now what is x of 2? X of 2 is 3. Okay, so now what is x of I? Means x of 3. Now what it would be equal to 3. So what we are doing is we are changing x of 3 to 3. So in this case, x of 3 would become 3, and everything else would remain same after the execution of the first iteration. Okay, now in the second iteration, see what we have, x of I would be, that is x of 3. Now x of 3 is what? It is 3, and x of 4 would be equal to 3. So x of 4 is x of I, it would be equal to 3. So x of 4 is already 3. So it is 1, 1, 2, 5, 6, 7, 8. All else are remaining same. Now here, x of 4 is equal to 5, and x of 5 would also be equal to 5. This is our question. So it would be same 1, 2, 3, 3. X of 4 is equal to 5, and x of 5 would also be 5. It is 7 and 8. Like this, until the last loop, we would get 1, 2, 3, 3, 5, 5, 7, 8. So the answer is A. A should be our answer. Okay. Next, which of the following has a compilation error in C? Actually, this one is right. This one is also right. This one is also right. There is no error. Here also it is a preprocessor directive, so there is no error. So the option can be D, because it is a preprocessor directive. So as such, there is no compilation error in all these statements. Okay. Next, okay, we have a for loop. for I is equal to 0, I is less than equal to 10, I plus plus, what we have to do is, it is a bitwise OR. Okay, so for I is equal to 0, 0 and 1 is 0. So it would be 0 whenever the least significant bit is 0. Okay, so for 0 the least significant would be 0, for 1 it would be 1, for 2 it would be 0, for 3 it would be 1, for 4 the least significant would be 0, for 5 it would be 1, for 6 it would be 0, for 7 it would be 1. That is alternating zeros and 1, which starts from 0. So A should be our answer. Okay. You consider the following statement. Okay, we have a statement over here, and this is called, okay, so this is a macro. Okay, define hypotenuse, it has been defined. So it is a square plus b square. This is a macro, and the macro called hypotenuse, that is a plus 2 and b plus 3. So after expansion it would be like a plus 2 cross a plus 2 plus b plus 3 cross b plus 3. So this would be our macro expansion. Okay, so now let's see. It is multiplication would be given higher precedent. It is 2a plus a, it is 3 cross a. Okay, it is 3b plus b plus 4 cross b, and 3 plus 2, it is 5 plus 5. So the answer would be D, that is the square root of, it would calculate the square root of 3a 4b plus 5. Okay, this is the answer. Next, okay, consider the C declaration. Okay, we have a structure over here, we have a union over here. So you have to remember one thing, that in case of union, the memory would be only one memory would be allocated. That is, the memory won't be allocated for different variables. The memory would be allocated for the variable which occupy larger number of memory. Okay, for example, here we have for float and long are there. For float we have 4 bytes, for long we have 8 bytes. So in case of union, we would be using only 8 bytes. Okay, but in case of structure, the memory allocated would be different for different variables. For example, short, we have short x, the short is 2 bytes, so there are 5 elements of short, it would be 2 cross 5, so that is 10 bytes. Okay, and 8 bytes for union. 8 bytes for union. So 10 plus 8, it is 18. So 18 is the answer. Okay, let's move on to the next question. Consider the following code fragment. Okay, this is a code fragment. We have to calculate the final value of x, both in the case of call by value and call by reference. So let's see the first one, that is call by value. Okay, in case of call by value, this is a main function. We have int x is equal to 5.5. It is an integer, so we won't be considering the 0.5. Okay, we are calling foo xx. Okay, we are passing 5 over here. So in this, x becomes 5. In this case, there would be some changes over in the call function. But in case of call by value, these changes won't be propagated here. So value of x remains unchanged. That is, x would be equal to 5 for call by value. That is, D option is wrong. Okay, it would be 5 by call by value. For call by reference, so what we are doing is we are passing x over here. So it is x and it is x. So we have x is equal to x plus x. So it would be 5 plus 5. It would be 10. And next we have x is equal to again x plus x, because this y is x only. So we would be having 10 plus 10. So it is 20. So now in case of call by reference, this value of x would be reflected in the main function. So the answer would be 5 and 20. That is, C is the option. Okay, next question. Okay, we have to see the output of the C code. So okay, we have a program over here. So in this we have k is equal to 5. The value of k is 5. Okay, so p stores the address of a k. That is, we have an integer pointer which points to k, and m stores the address of the p. So we have a integer pointer which points to p. Okay, so star p would be 5 and double star m would also be 5. So what we are printing k, it is 5, star p is 5 and double star is 5. So 5 should be our answer. Okay, this is the answer. Next, what will be the output of the program? Assume that you are running in a little Indian processor. So this is the main problem thing, little Indian processor. When we have a little Indian processor, then the lowest significant bit would be considered for addressing. So first what we are going to show is we have to convert 320 into binary form. So we convert it into like this. So we have 8 bits over here, 8 bits over here, total 16 bits. So this is MSB bit and this is LSB bit. So we are using little Indian. So this bit would be used for pointing the addresses. So after calculating it, it would be 64. So answer should be 64. But if it was big Indian, the answer would have been 1. But if it is little Indian, the answer is 64. So 64 is the answer. Okay, next, if a class C is derived from class B, so C is derived from class B, B is the parent, and B is derived from class A, that is B can access all the public and protected data of A, and C can access all the public and protected data of both B and A. So the option is D. Okay. Next, which of the following operators cannot be overloaded? Okay, now the questions we are discussing is of ISRO 2017, asked in the month of May. For the questions of December 2017, you can see the whole video. I have uploaded all videos of all the questions from 1 to 80. Okay, so this is for May 2017. Okay, so now let's see what of the operators which cannot be overloaded. Okay, the conditional operator or the ternary operator, it cannot be overloaded. The member selection operator cannot be overloaded. So this cannot be overloaded. This cannot be overloaded. The member selection with pointer to member, it cannot be overloaded. Scope resolution operators also cannot be overloaded. So in our cases, the answer is D. So there are more operators, that is size of, type ID. These all operators are the operators that cannot be overloaded. So the answer is D, all of the above. Next, what is the output of the program? Okay, so before going on, we should know what is fork. Whenever fork is called, a child process is generated. Okay, so when we call a fork, there are two processes. One is the parent and another is the child. The parent process, it returns an ID. Okay, and the child process is returned a 0. So when a fork, it takes no parameter and returns integer value. The value can be negative, 0, which is returned by the newly created child process, and positive value, which is returned by the parent or the caller. And if it is negative, that is no child process has been created. So here we would be dealing with only 0 and positive value. Okay, so let's see the question. We have int a is equal to 10. So a is initialized to 10. If fork is equal 0. Okay, see, when fork is called, two processes would be generated. One with the process ID, which is not 0. Another is the process ID, which is 0. Okay, so this condition is satisfied by the child process. So child process will print A++, will print 11. For child process, it will execute this and then it would print this. Okay, for the parent ID, it would directly print this. So first the parent ID would print 10. After that, the child process will print 11. So the answer would be 10 and 11. Okay, because the parent, it would not be equal to 0. It would be some valid number. So it would be equal to 1. So the next statement, it won't be executed. This statement would be executed after checking the condition, because the condition becomes false. So answer is 10 and 11. Okay, next. Consider the following. So we are swapping. Okay, we have integer temp. It is a simple swap function. Okay, so in order to exchange the values of two variables x and y, so how can we call it? Okay, in this there is no problem. Okay, this is right. In this it is a problem, because if we have ampersand over here, then it should be here. It should be a pointer variable. If we are passing address, then this address has to be stored in some pointers only. We cannot store it some in normal variables. So this is false. This cannot be true. So B is the answer. Okay. The reason is we are passing addresses over here, and addresses can be stored in some pointers only. So this has to be pointers, but these are not pointers over here. So this is the answer. Next, what does the function following statement declare? Okay, we have something like this. So let's see, a function that takes an integer as a pointer, an argument, integer pointer as an argument, and returns an integer. Okay. See, taking integer pointer as an argument and returning an integer. This should be our answer for this statement. Okay, for next statement, a function that takes an integer as the argument, it is taking integer as argument and returns an integer. Okay, integer as an argument and returns an integer pointer. Integer pointer is being returned over here. Okay. Now, a pointer to a function. So we are pointing a function that takes integer pointer as an argument. It is taking integer pointer as an argument and returns an integer, and it returns an integer. Okay, so this is our answer. This is same as this. C is the answer. Okay, next question. What will be the output of the C code? Okay, we have a code and we have to tell what is the output of the code. Okay. See, now we have int I for I is equal to 0 to I is equal to 5, I plus plus, I is equal to 10. So print I. So it is a simple C programming. We would be printing I 5 times. Sorry, 10 5 times. Okay. So it would be our answer. It is very simple. We are having I is equal to 0, 1, 2, 3, 4, and every time 10 is printed. Because every time I is initialized over here. So irrespective of what is the value here, I would be printed, because every time we are, if it was static, if the variable, the name static was there, then the answer would have been this. But there is no static, it is not a static variable, it is a normal variable. So every time 10 would be printed. Okay, 5 times. So this is the answer. Next, what does the following program do when they input unsigned 16-bit integer? Okay. So we are talking about unsigned 16-bit integer over here. Okay, unsigned, so int num, we have a number. So for our reference, we can take the number as 3. Okay, I'll take the number as 3. So we are, here see, we have two operators. One is the left shift, and another is a bitwise AND. So priority of the left shift operator is more. So first this statement would be executed, these two statements, and then an AND operation would be performed between these two. So first what we are doing is, we are left shifting 1 15 times. Okay, so 15 times 1 has been left shifted. 1 was here, so I have left shifted 1 by 15 times. Okay, now what I would be doing is, I would be, let the number be 3, that is 1 0 1. I would be shifting 3 I times. Okay, so for I is equal to 0, so 0 times I is shifted. So this would be the answer. Okay, and then I will be performing in the AND operation. So it is like, this is a condition. If this condition is true, then print 1, else print 0. This is the thing. Okay, so when you perform AND operation between two, this is false. So 0 would be printed. Okay, for I is equal to 1, I will be shifting this by left side by 1. So I have shifted it by 1. So when I shift it by 1, 1 0 would precede it. So the answer, now also AND operation, 1 1. Okay, here it is 0 only. When I shift it by 0 0, 1 0 0 0 0 0. So after that also it would be 0. Now for I is equal to 2. This is 0, sorry. For I is equal to 2 also, it has been shifted 2 times. 2 zeros are there. So this is also 0. Similarly for 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. For I is equal to 12, we would be having 12 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Sorry. For I is equal to 13. Sorry, it is for I is equal to 13. For I is equal to 13, we would be having 13 zeros. Okay, now when we perform the AND operations, so see we have 1 and 1. Okay, the most significant bit would be displayed. So 1 and 1. So it would give, this is 0 and 0 0, 0 and 0 0, 0 0 0 0, all are 0. But here we are having 1 and 1. So it would give 1. Okay. Now similarly for I is equal to 14, it would give 0 only. For I is equal to 15, it would give 1. It would give 1. Okay. So the answer is 101. See, it is what it is giving. It is giving the binary form of the number. So it prints the binary equivalent of the number. Okay. So next question. What is the output of the following program? So okay, we have temp 20. It has been initialized. Printf temp. The first time 20 would be printed, because we haven't made any change. So option D has been cancelled. So now we are calling the function fun. Function is called. Okay, when the function is called, so we have a temporary variable 10, this static int temp 10 and printf temp. Now when we are printing temp here, so 10 would be printed. Okay, now this static, it is local to this loop. This value would not reflect over here. Okay, then this temp is printed, so it would print this original temp only, because it is the global variable. So it would print the original temp only. So the answer should be 10, 20, 10 and 20. Okay. Next, we use malloc and calloc for dynamic memory allocation. It is used for dynamic memory allocation. Let's see what is malloc and calloc. Malloc takes single argument, the amount of memory to allocate bytes, while calloc needs 2 arguments. So you have to remember, malloc single argument, calloc needs 2 argument. That is, one is the amount of memory and size in bytes of a single variable. Okay, so take 2 variables, and also there is one more. Malloc does not initialize the memory allocated. In malloc, the memory is not initialized, whereas in calloc, the memory is initialized to 0. So you have to remember these important points. So for dynamic memory allocation, malloc and calloc are used. Next, which of the following is the superclass of all error exception in Java language? It is throwable class. It is the superclass of all error and exception class in Java language. Okay, thank you. This was all about the programming language questions for the year 2017, 16 and 15. Please watch for further videos like this. Thank you.